We've prepared some laboratory simulated experiments which demonstrate the performance of BondTAC elastomeric membranes under the most adverse and severe conditions that one can experience out in the real-life situation. We've taken a series of aquariums and used a variety of building material substrates as dividing walls. In this instance, this aquarium over here, we have inserted a next-gen cement board, 1/2 inch, as a dividing wall in the aquarium. We've sealed the top after having coated 2 coats of BondTAC 1500 clear on one surface of the next-gen cement board. Top is sealed over here, so we have full water immersion in the bottom part and 100% relative humidity situation in the upper level in this sealed chamber. This aquarium was prepared on March 11th, 2010, and today, September 2nd, 2010, represents about 5 months complete immersion at the bottom and 100% relative humidity on top without experiencing any penetration through the substrate. On to the next aquarium. We've simulated the same experiment on the same day, March 11th, 2010, where we've used tile backer fiberboard as the dividing wall. Coated as well with 2 coats of BondTAC 1500 clear elastomeric coating. You've got the water at the bottom component of the aquarium and 100% relative humidity situation in the upper chamber. The third one is using gypsum core exterior sheathing. This one happens to be glass mat gypsum core sheathing by Canadian Gypsum Corporation. It's the same as dense glass gold by Georgia Pacific. These exterior sheathing products are suitable for weather exposure, for exterior exposure, but they're not intended for water immersion and most certainly not intended for cascading water or conditions as adverse as we might experience here. Bottom portion, of course, fully immersed in water without any impact on either the glass mat layer or on the gypsum core. No penetration at all. In fact, what we have done over here is we've taken the glass mat exterior gypsum core sheathing and coated it fully with the BondTAC 1500. Immersed it in this glass jar so that the entire product is immersed on both sides, and sealed it in the jar as well on March 11th, 2010. I'll open up this glass jar just to take a look at what's happening on the inside. In immersing this in BondTAC 1500 to coat it, we actually inserted a screw into the gypsum core and dipped the product into the elastomeric coating. As you can see over here, the component of the screw that was actually coated during the dipping process experiences no corrosion whatsoever in the water and high relative humidity, 100% relative humidity environment. The component of the screw that remains uncoated, that was held during the dipping process, is severely corroded at this point. Let's move on to our next demonstration, which as well, is water immersion and high humidity levels. In this instance, what we have is just ordinary gypsum drywall board, 1/2 inch, which we've coated with 2 coats of BondTAC 1450, similar to the BondTAC 1500. That was coated on October 31st, 2009. Today we're on September 2nd, 2010, so it's approaching 11 months. We have complete water immersion of the drywall. We have 100% relative humidity in the upper chamber. This is a 10-gallon aquarium with insertion at the 5-gallon point of gypsum drywall. You can see some decorative stone on the other side being held up by a water-based acrylic ceramic adhesive, and the drywall is completely intact after 11 months, no penetration through the drywall, and certainly no damage on the interior of this aquarium. We've taken another example here which might represent a severe situation for a foundation wall or a subgrade wall. We've inserted in the center of the aquarium half-inch cement board to attempt to simulate a foundation wall of poured concrete. We've actually damaged the cement board, deliberately cracking it at various points to try and simulate a situation where you may have shifting walls, cracking walls, damaged cement walls, and are experiencing moisture or water transmission through the cement to the interior of the property. We have coated the exterior of the cement board with 2 coats of BondTAC 1450 in this instance, and we've filled the aquarium about 2/3 of the way with water. So what you've got is an exterior foundation wall that's been immersed, totally immersed in water now for almost 11 months, and a 100% relative humidity situation in the upper chamber, which would be most extreme under any circumstances. And the interior of that particular wall inside this aquarium has remained bone dry for that entire period of time without any water or moisture transmission through the half-inch cement board. We've taken another situation where we've actually reversed the cement board. What we've done is as well cracked half-inch cement board, and what we did was we coated the inside wall of the cement board, representing perhaps an interior coating of BondTAC elastic membrane to repair a leaking or damaged wall. This would not be a recommended procedure on a permanent basis. We would always suggest that you do your exterior excavation and the appropriate repairs to your cement, because as is clearly observed, there continues to be deterioration and erosion of the exterior cement, which has been immersed in water. You can see as well the color of the water over here, demonstrating that there is ongoing and continuing problems. What we have achieved, however, is by coating the interior wall, we've prevented moisture or water from penetrating through to the interior of your basement or parking garage and creating damage such as rot, mold, warped wood floors, spewing paints, and so on. So we would recommend this as an interim repair procedure where access to exterior excavation, is not convenient or possible at a particular point in time. This, of course, now has been immersed for 11 months, so it's been an extended period of time, and certainly the interior coating reflecting a situation of reverse hydrostatic pressure demonstrates that material such as BondTAC elastomeric membrane can be used for interior repairs and will protect the interior of properties and foundation walls for a period of time until such time as exterior repairs can be conducted. One of the benefits of the BondTAC elastomeric coating is, aside from its ability to penetrate into substrates and bridge cracks and fissures in walls, is that in fact it will accommodate movement and settling of properties and walls and opening and closing. It does have memory as well, so it will move with the wall for continued protection even though damage is continuing, and continue to protect for a period of time. Let's take a look at this demonstration over here. We've got some aluminum dishes coated with BondTAC 1500 elastomeric membrane. What we've done here, okay, is we will separate and pull apart this dish which I've just cut, and you will see that as I pull it apart, the actual BondTAC 1500 membrane, I'm trying to do this, will stretch and yet continue to provide continuous coverage and protection with the moving wall as it stretches, moves, settles, expands and contracts under certain circumstances such as cold and warm weather. You can see what happens as I release this. The metal retracts, so the coating does have a memory. It will move out like this, and with the wall as the wall is moving, and at such time as the wall shifts back into the original direction, the coating retracts just like a rubber band. Now, of course, when using protective coatings in conjunction with building materials, there are issues that may come up, such as building code requirements and so on. One of our concerns, of course, is with a polymeric, elastomeric material, is how susceptible it is to propagating the flame spread as well as smoke development should there be a fire inside the particular property. So we've taken a look, and as tested by Underwriters Laboratory in Canada, our product conforms and meets all code requirements with respect to CAN 4 ULC S102. In fact, the BondTAC is so resistant to flame and fire and smoke development that it will actually withstand temperatures well in excess of code requirements as high as 4,000 degrees Fahrenheit. We've got here a sample of a product which most of you might be familiar with. It's stone wool, mineral wool by Roxville Corporation. They advertise that it's a thermal barrier for a number of applications. In fact, most of their advertising indicates that stone wool does not burn. Well, it does not really burn. It's not a combustible, but it will decompose under extreme temperatures and flame. For example, we have here a high temperature brazing torch which runs between 3,500 degrees and 5,000 degrees Fahrenheit for brazing and melting metals. As you can see, the stone wool, of course, has resisted total decomposition, but it has been badly damaged, charred. The surface, of course, has been affected. It is collapsing, and it did generate some amount of smoke during the process. Let's apply the same test flame to a cement panel coated with BondTAC 1500. Again, when we tested this product at the ULC testing facilities, we found that there was no deterioration whatsoever in the product on a 24-foot length exposed to 550 degrees Celsius over a period of 10 minutes. But to take an extreme situation, what we would want to do is subject it to much higher temperatures than that, far in excess of building code requirements. As you can see, the BondTAC 1500 elastomeric membrane is subjected to temperatures in the range of 4,000 degrees Fahrenheit, would not show any deterioration whatsoever, does not show any generation of smoke whatsoever, and in fact the surface has not discolored at all. It still has the retained yellow color as originally coated. If we touch that area in which the flame was applied, it retains its tack. It's still coating The cement board, in fact, its functional performance remains as before in spite of being subjected to flame at those excessive temperatures.